Great to be here with everybody. Brandon Whitelaw, VP of Cloud. Just for context, as I'll talk through some of the stuff, prior to Qumulo, I ran worldwide storage strategy for AWS for 3 years. Prior to that, 12 years with one of the leading NAS vendors out there, as well as chief of strategy. So kind of seen it on both sides of the fence, trying to build hybrid multi-cloud strategies from on-prem in, with the messaging that went along with it, like why put your data there and then rent it to get it back? Or you don't want to trap your data there and all the stuff that goes with that. And then the inverse position, obviously, on the AWS side of things of how do we unblock customers that are just saying, please take my money, I want to move it there, and help unblock these workloads from getting there. A couple things, overall, it's funny how we see these ebbs and flows within IT history continue to repeat and history repeat over and over again. There's no original. There was a long motion for a long time to figure out how to become basically a consolidation play to try to get all the disparate file systems into one single scale-out system and be that company's global file standard. And that was a long play for a long time, worked really, really well, but unfortunately the game has changed. The rules have shifted, and there's virtually nobody out there that isn't doing something with data in a cloud or multiple geographic sites or multiple clouds. In fact, 84% of all companies have adopted a hybrid strategy. Surprisingly, 94% of them have a multi-cloud strategy or are already using multiple clouds. And by the way, there's a bit of a misnomer there. It's rare to actually see a company that has the same workload in multiple clouds, but often they'll say, oh, this part of my business is better in Azure, but this part I'll do in AWS. And this one particular thing, despite my desire for it not to add complexity, this one engineering group wants to do that one thing in GCP, and it drives me nuts, but so be it, right? So there's at the end of the day, the control factor, the ability to just have everything on one platform, one vendor to deal with, is basically gone for the most part as you start looking at where data needs to be, and more importantly, how especially file data has really shifted from what was historically kind of second, third tier, it's okay, it's not critical, it's home directories, who minds, up to now the most critical data as far as the next gen wave of applications, especially considering AI and everything else coming with that. So part of the historical challenges that come with it is that most file systems can really only run on one platform. If they do run in cloud as well, it's often a very minor version of their full self. Think, fun size candy bars at Halloween, not the full bar, okay? Usually 1/100th of their performance scale, and unfortunately, on average, about 3 to 20 times the cost per terabyte fully burdened. So it's not the most appealing pitch, so to speak. It's like, yeah, technically it's there. I can check the box and say that I'm in cloud as well and can do hybrid cloud. But if none of the principal economics line up, it kind of defeats the point. And don't get me wrong, those systems, believe it or not, are multi-billion-dollar systems growing very, very rapidly, but it is in spite of those barriers, not because of the attractiveness of it. And I can tell you myself, if you take just about any file system in the cloud today, while extremely capable there, comparatively to the pedigree of what's happened over the last few decades on-prem, is pretty far behind for the most part. And the last bit is data access. So it's one thing to go say, I'm going to go rip this data away from the data center and throw it in the cloud. The number of times at AWS, for example, I had someone say, yeah, I'm going to just move my home directories from on-prem into the cloud. I'm like, cool, so you're going to move everybody to like virtual desktops as well to access it? No, we'll just keep it all exactly the same on-prem. Cool, okay, have you ever worked with SMB over a WAN? It's not really meant for that. It's not going to be a great experience. All you're doing is pulling the data away from your users. Not maybe the best idea, right? So at the end of the day, what we want to try to do is be able to help people connect their data to any services and users in a highly visible, highly accessible, and very performant way, and avoid a lot of the solutions to this problem to date, which is to really just mirror or replicate data. Just go create a bunch of copies. The last bit is that the irony of the situation is we have things in the wrong places, so to speak. We have about 90 to 95% of all unstructured data in the cloud is object. You have almost the inverse on-prem is file out of the unstructured data, just unstructured data. And the vast majority of all data that needs to serve and feed next-gen AI models and all the things that we talk about is this unstructured data sitting on-prem. It's between 100 to 200 exabytes, depending on which analyst you believe in how hyped up on caffeine they are. Okay. But the vast majority of, especially from a customer count perspective, let's ignore the high peak of the hockey stick for those buying, 1,000 or 30,000 GPUs for a moment. The vast majority from a customer count perspective of the GPU accelerated workloads are actually happening in public cloud, but all the data is sitting on-prem. And so we have a problem where if you could get visibility and access to the data and seamlessly connect it into those cloud services, not just for AI, but a myriad of other things, and there's a bit too much probably going on of layering AI over every possible computational process that exists out there, then we can really get into something quite good there. So what we often see from customers is a situation kind of like this. Within their core data center, let's call it just their primary data center, we have disparate silos of data. At one point in time, by the way, it was pretty close to being just one data platform. And nowadays, we're seeing actually a reemergence of silos and kind of ponds of data, maybe dedicated to particular line of business use cases versus core IT, or particularly to a dedicated AI pipeline, or a separate, disparate archive or backup system, or video surveillance, physical security, you name it. Actually seeing the number of systems expand, adding complexity and cost. Often they have a DR colo facility that they replicate to as well. Sometimes those are even different systems and disparate or separate for each one of those primaries. More and more and more, especially post-COVID, we see a lot of companies that have disparate teams. Maybe they have edge branch locations. Maybe they have just virtual teams that are connecting in different places. So they're not all coming into the office and working in one central location. And then, like I said, most are using public cloud in some way. And each of those different primary workloads you do in the cloud are generally done on different storage. So you might park it in S3, but you'll copy it out into FSx Windows for that workload, or EFS for that workload, or FSx Lustre for this different one. And now all of a sudden you're making copies, and of course,
you did work for AWS.
I did. So you can check. Anyways, the background also is that the challenge is every single time you move data is not for nothing. You pay money every single time you move data. So it takes time, it costs money. And then you might have a different public cloud, obviously, that's doing a whole different set of things, depending on where the most available service is and what you like that per particular time of day. So at the end of the day, you have a lot of disparate systems. You have a lot of data that's duplicated in many different places because of this, mirroring or replicating between systems. And it's ultimately very, very difficult for anyone to keep up with this because the schools, the frameworks, the tools, the monitoring, all the systems to look at what's happening and how people are using data are actually different between these systems. You can't completely control that ecosystem entirely yourself. That becomes a big challenge. So what I'll talk through today is, how do we get to what we consider a better outcome state, which is if we could have it to where I can consolidate all those disparate workloads of the core data center, being able to have the DR colo also be the same system, natively replicating to it, but by the way, also make that feasible to put in cloud at economics that makes sense. Be able to have an Qumulo edge running at either remote regions or offices that is not requiring a full physical appliance that can run containerized, virtualized, or something that's very, very low cost and impact for the needs of that particular set of users. Be able to have a common data fabric within each of the public clouds that are the same and has the capabilities and economics to be the primary location for all that data. We'll talk about how we do that as well quite a bit today. And then again, make sure that you have visibility and access through Nexus, not both from real-time file system analytics of how people are using the data, but also through that global data fabric, making it so that any data, no matter where it is visible and accessible by any service, any compute, any GPUs, and any people necessary for it. So
Brandon, you mentioned that, I should say your CEO mentioned that the global namespace was read-only now?
Right at this exact moment, correct. Right around the corner to read-write. Yeah, so I'll talk through some use cases of where customers are using that. With the
and the global namespace is the solution that provides data consistency across all those locations?
Accessibility and visibility with strong consistency. So ultimately, how do I get users?
When you say strong consistency, you're talking about written in one place, available to all?
Mm-hmm. With directory level granularity, relationship between how you want that cached and how, whether or not that needs to be on demand or aggressively preemptively cached into those, depending on the type of file and users and workload, or full synchronous, like no matter what magic we do, the workload is so latency sensitive that you need full caching of that into that remote site. But the hub, so to speak, or the home of the data, where I'm basically ensuring both consistency, locking, but also data protection, is somewhere else.
And the caching is available through each of these solutions, the CNQ, the Qumulo core, et cetera.
Yeah, in fact, it's by directory. So any device that is, or any system, so it could be an appliance in the core data center, could be an edge containerized system running, in a Home Depot store, could be in AWS, Azure, you name it. Any of those can be the hub or home for that data and create a portal from that into any other system specifically for that directory to give visibility and access. So instead of kind of an all or none, it's very directory level granularity, which I kind of consider almost even a federated namespace, so to speak, where we have customers that's, when we first talked about all this together, like, yeah, non-starter. I cannot, with GDPR, with data sovereignty, with this, that, the other, I cannot have everything visible to everywhere. Like, don't worry. You have the controls and granularity to decide where it's shared with what group, different systems. Not only that, but how it's shared. In fact, we have customers that particularly want to do a zero cache share, meaning I want visibility and access and accelerate that WAN optimization, but no data can reside in that remote location, right? Particular entities that can't use public cloud, for example, but want to use cloud services. The law says I can't actually store the data in the cloud, but I can remote access data and then process it in the cloud, as long as it's never stored there permanently. Things like that.
So, I mean, the edge branch thing, could that be at the level of PC workstation kind of thing, or is that more or less a real server type of? Edge has kind of got a lot of different dimensions.
Where are we going? Yeah,
are we talking a Raspberry Pi solution, or are we talking about a Dell server edge?
It's very flexible. I would say today what we're predominantly targeting is customers to say, look, I have a single server with containers or VMs there, or I have a hyper-converged system. The whole point is I don't want to have a dedicated piece of hardware just for storage. If you have 4,200 stores, what's the most common singular piece of hardware that's easiest to maintain and deploy that I can put this on, along with all my other applications, point of sale, everything else on that same system?
When you say put it on, is that a reference back to it's an RPM? It's something that a person that's comfortable with doing apt get the thing that's going to solve my problem, they can do.
Yeah.
Okay.
Absolutely. Not only that, but being able to have a system that is end-to-end, soup to nuts, from ground up, entirely API driven.
Okay.
So you can automate every aspect. There's no aspect of the system that can't be done through an API orchestration layer.
And you said you're going to go into some of the examples that were talked about previously. Okay.
Yeah. Thank you for that. So I'm going to talk on 3 core technologies. I've alluded or preemptively talked about what we mean by our cloud native file system in Azure, AWS, et cetera, our global data fabric, and then the run anywhere technology, which we just talked about here for a moment. Okay, so some preface. So here's the interesting dilemma for file systems in cloud, is most file systems in cloud were either kind of lift and shifts from on-prem and tried to just replicate and emulate exactly what they had on-prem. So how do we make something look like a node or a filer, right? I get some EC2, hang some EBS off of it, boom, done. There you go, have a good day. Or secondarily, they were a homegrown kind of native built system like EFS, for example, or Azure Files. And they're really good at what they do, but they were built with particular customer problems in mind. And then, as over time, they ended up getting used for a lot of things they probably weren't meant to originally be used for. Okay, so you have definitely a place and time for all these things, but for the vast majority of, I would say, the high capacity, high performance file data sitting on-prem, it's a pretty tough transition into that space. Now, on the other hand, you have S3 or Blob, for example, which are brilliant products. I mean, you'd be blown away. I'll tell you later about the amount of capacity added globally to S3 on a weekly basis is more than most storage companies ship on an annual basis, okay? Or actually probably over their entire lifetime of the storage company. So it is amazing, immensely cost-effective, elastic, scalable, extremely durable, both Azure Blob and S3. But here's the problem. They were never meant to be a file system. So if you look at latency, you look at transaction per second limitations, you look at just protocol compatibility, application compatibility, it's not there. And the early messaging was, oh, hey, if you really want to get, take advantage of cloud, just rewrite all your applications to be cloud native. That's simple, right? Just rewrite everything to support, S3 natively or Blob natively. Well, okay, maybe that worked for certain things, but it becomes really expensive as a pathway to cloud for a long time. So the average timeline to migrate a workload that had to be replatformed into object from on-prem for AWS was 24 to 36 months, with hard engineering time dedicated to that and not front-end customer-facing features or functionality. That's a pretty expensive price to pay. But the average time if you went file system to file system was less than 3 months. Don't change the application, right? Just move the application. Now, obviously, there's more complexity than that, but at a high level, it's keep the app the same, point it to the same NFS or SMB share, off you go. So that's great, except for now we have the file systems that, because they were built on EBS, they are relatively expensive, like I said, about 3 to 20 times dollar per terabyte per month than fully burdened systems on-prem on average. They're inelastic, so you either have to hard provision capacity, or you can grow it but can never shrink it, with rare exception. They're relatively complex. Even though they're managed services, they often have more points of management than self-managed Qumulo. So it's a interesting challenge there. And I would say even more than the file system itself, where the complexity comes from, is just orchestrating data. So again, because of the expense and limitations in how much they can scale and things like this, 64 terabyte limit on FSX Windows or something like that, you end up putting all your data in S3 and then having to orchestrate data pipelines that copy it into the file system, do the thing, and then put it back out. So I just have the least amount of time. They're very transient. They don't just park it there. And then very limited in capacity as well. So how do we change this? Well, ideally, I have my cake and eat it too moment, which was, how do I get all the benefits of S3 or Blob, but none of the downsides, and then keep all my benefits from a 7-year Gartner Magic Quadrant, fully mature file system with a multi-protocol stack and endless scalability and performance? Like, how do we bring those things together? So, creative approach. First thing is, look, the only way you're going to drive down economics is the data has to be stored on the object layer. It has to be on S3 or Blob. You can't do it on EBS. There's no way you'll get the economics in line to on-prem if you store it on EBS. It's just not going to happen. Back in previous days, if you were to go take a file system and build it on top of expensive SAN storage, yeah, that'd be pretty hard to hit the price point of like cheap and deep scale out NAS storage. That's effectively what's happening there. So the first thing is all data and metadata has to be able to persist on S3. More importantly, take advantage of all types of that object storage. For this, I'll talk about in my native tongue of AWS, but you could translate identically to Azure for the same things. So you can use any tiers of S3. In particular, we did a lot of optimization work to use S3 intelligent tiering, which is phenomenal. Helps with a lot of lifecycle management automatically for customers that they go, yeah, I don't know, 80% of this data is cold, but I don't really know what. Great, let's go take advantage of that. Drop the price down 5-fold when you go from standard down all the way to the glacier instant retrieval. And you don't have to manage anything, you don't have to set policies, and your performance is identical regardless of what tier it's on. That's really, really important. So end users never see an impact of that cost savings whatsoever. Then we had to make sure we don't mess it up and constantly touch the data to re-promote it. That's kind of key. So all data and metadata is persistent on S3. Okay, cool. You go, great, but remember all those problems with S3 or Blob for a file system performance? How do you solve that? Well, 2 ways. One, first, you collaborate really closely with Azure storage engineering and AWS storage engineering, which we did. And you try to figure out how you can lay out the data in a very different way. Now, there are benefits to 2 approaches. Either a file equals an object, and then it's native, and it can be used through every other service in the cloud, great. Or you kind of use the object layer as a big disk. And you use as many different buckets and prefixes to stripe data along all of it as much as possible. So instead of looking like 1 customer, it looks like 1,000 customers. And I get over all my transaction per second limitations. Some really elegant prefix logic of how we do that. That's the first step. That helps with transactional performance. It also mitigates some tail whip latency concepts of where I can pull the data in what order to get around if a particular prefix stalls. But there's 2 ways that performance is built under the covers of S3 or Blob. There's hard provision performance and adaptive performance. So
just a point of clarity. If we're doing this, we're doing this through Qumulo. We're not doing this in AWS and then layering that's on top of it, correct?
Correct. The Qumulo is, I'll show you the full stack when we build it out, but S3 is the core component in the customer's tenant. And the Qumulo file system is doing all that orchestration, all the data layout, all the encryption and how we lay out the data to make it as easy as possible.
It's another layer of abstraction on top of S3, wherever S3 is there.
Correct. So I'll show you how we build out on top of that one. But part of the key aspect here is being able to stripe data across S3 to use as much as the pre-provisioned performance boundaries instead of adaptive performance. Because what you don't want, normally if you go to S3 and start hitting it really hard, it'll take it for a little bit, and then it'll go, oh, 503, back off, you've hit a limitation. If you keep doing that for long enough, they'll just go provision more performance behind it, spread the load, you'll get more performance out of it. But no artist editing the next avatar is going to wait 5 minutes for the performance to come back. They'll be pissed off and walk away, and you'll lose primary time with that person. So you can't have that. So we designed it specifically to avoid that in every way. It specifically uses all the secret provisioning under the covers to make it so that we can get around all those boundaries from the first place. In the words of one of the principal S3 engineers, you're hacking my S3. That's pretty cool. Let me help you do it a little bit better. Okay, so that's the first layer.
You support S3 Express?
Yeah. But there's very limited use case for that. You're talking about Express One Zone?
Yeah.
So yes, we can, but yeah, extremely expensive, very limited use cases where we've seen that as a possibility. In fact, we have some customers that are, I will say, considering moving from S3 Express onto us based on getting actually better performance, better latency, and I don't know, in the realm of about 10 times the performance, or 10 times the cost, 10 times reduction in cost. That's a better way to phrase it.
It's like when someone says you're holding it wrong, you're helping the people not hold it wrong.
Yeah, exactly. Now, the second thing that's really important here is how we interact with the data from this point. So one of the core technologies from the beginning was having a real-time file system analytics running off of a 4K heat map of the file system, not resolution block size. I have to be careful. A lot of our customers are media customers. They're like, why does the resolution of the film matter in this? Anyways, 4K blocks. And what that does is allow us to preemptively cache data based on the probability of it being accessed. So there's effectively looking at that heat map and then trying to figure out how to avoid direct latency hits into that system. That then goes into this layer. So within EC2, we use NVMe as a read cache. It's a globally coherent cache that sits across all the EC2 instances that are running Qumulo's file system. And this allows us to pull data preemptively into that cache and or store it there so we can avoid going to S3 as much as possible. Now, normally in a file system, you get most recently read and written data into cache, maybe 25, 30% cache hit rate. As Doug alluded to, our global average across our fleet is about a 94 to 95%, depending on the cloud, cache hit rate on the read cache. So there's two benefits to that. One means that 94 to 95% of the read IO is straight out of NVMe and not going to S3. That's good. The second thing is a massive reduction in get and put requests from an API perspective. So it's not uncommon for a customer on S3 to see between 15 to 20% of their cost be API charges in listing, inputs, and gets, et cetera. Our global average is sub 1% for customers. So whatever you're paying for S3, take 1%, that's your API charges on average. So again, helps reduce the cost immensely, and there's two parts to that, the read cache and the write cache. We write data to a SSD mirrored EBS volume for consistency, and that does two things. One, we pack a bunch of small files into big objects, so we get one put instead of like 1,000 puts. We also compress the data. So the compaction and the compression help avoid a ton of API charges down into it as well. From there, you can take the front-end performance of EC2 from a bandwidth perspective. Almost all the performance, by the way, is going north-south. So we have full read-write through semantics, and it makes it so you can have direct access, even if the data is not sitting in cache. You never have to wait for it to lazy load or warm up or manage how much data is in cache. There's nothing related to that. There's no cache management whatsoever on your behalf. But the EC2 layer can be expanded. So you can go from 3 nodes to 100 nodes, back to 3 nodes. In fact, Dak's going to show you that in just a moment. And that can be done in minutes. Now, by the way, it sounds like, of course, you should be able to do that, but that's actually really rare in cloud. Almost no file systems have elastic performance, and almost none of them can actually shrink. So that is a huge benefit in keeping costs down. I'll show you an example in just a moment. You present that all through a single volume, single namespace. You don't have to deal with aggregates or LUNs or anything else.
But before you, I got a little confused there. So the EC2 layer is simply a front end to the storage, right? So you're just running a bunch of storage APIs that we get access to, that we use, and those APIs are running on the EC2 layer.
So EC2
Yeah,
different
so
than
right-
NVMe cache?
Like this. So what we call cloud native Qumulo is the combination of these components.
Right.
You have a multi-protocol front end where you can speak any protocol to any of the data in any directory. That is full permission enforcement, SMB, NFS, S3, you name it. And down through EC, now that file system is running on the compute of EC2. It's using the NVMe cache inside that EC2, and then it's storing it all in S3. In fact, I would say a more technically accurate diagram would look like that, which I'll hand over to Dak to talk through and then actually show you how fast and easy it is to deploy.